This lesson is about comparing decimals. One of the easiest things that I like to do to find it helpful to compare decimals is that when I'm looking at different numbers with decimals, I like to line them up all by the decimal point. So if you notice here, if I'm talking about one whole, I would put a 1 to the left of the decimal point, representing one whole. Now if I move one more place to the left here, I have now increase the amount that I have to 10 wholes, or by a multiple of 10. And in fact, if I move one more place value, I now have 10 times more than 10, 100. And if I move one more place value to the left, I now have 10 times more than 10, or 1,000. Now, the opposite is true on the right side of the decimal point. So if I only have digits to the right side of the decimal point, I actually have something that is less than a whole. So I would put a 0 here as my ones. And if I have 1/10, that means I actually have 1/10 of a whole. And we can think about that as far as the size by using this visual model of a tenths grid. So 1/10 means that I would just shade in here this first column, and that would represent 1/10. Now let's say that I had a 1 not in that first place value, but in the second placeholder there. So this represents 1/100th. Now if you look over at the hundredths grid, 1/100th here is quite a bit smaller than 1/10. And you can actually see that it's actually 10 times smaller. So you can think of this as every time that we move one place value to the right, we're actually looking at 1/10 of the previous place value, or we're taking each of those and dividing it into 10 parts each time. So now if I have 1,000th, I would have 2 zeros here as placeholders, and the 1 would be in my thousandths. And I actually have even a smaller piece yet here, just this little 1,000th here, which is 1/10 of a tenth. And I would write that here as 1,000th. So now let's take a look at equivalent decimals. Let's say I had a decimal here of 0 and 2/10. If I look at my tenths grid, that means that I am shading in 2 of the tenths, which would be represented here by shading in 2 columns here. Now I want to look at this decimal here, which we would call 0 and 20 hundredths, because the last digit here ends in the hundredths column. So if I use my hundredths grid to shade in 20 hundredths, each one of these columns represents 10, plus another 10 for the second column gives me a total of 20 hundredths. Now you'll notice here that I have shaded in the exact same amount as the 2/10 here. So these are actually equivalent decimals. Now let's look at one more of these, 0 and 200 thousandths. I now have moved 3 place values out to the thousandths. So if I want to shade in 200 thousandths, each one of these is 10, 20, 30, 40, 50, 60, 70, 80, 90. There's 100 in one column. And so if I want 200, I just have to shade in all 2 columns. And again, you can see that 200 thousandths, is the exact same amount as 20 hundredths and 2/10. So we call these equivalent decimals. Now notice here that the only thing that is different when I write this as a decimal is that we end up having zeros to the right of the last digit. So anytime that we do that, we're not changing the amount we're talking about. It actually represents the same amount, and therefore those are called equivalent decimals. Okay, now let's look at the problem that was on your last unit test, where we were asked to compare 5 different decimals. So what I've done first is I've written all of those decimals in this chart so that I could easily line up the place values. So if I line them up all by decimals, I can see how many ones right here are in each of those numbers, how many tenths I have, how many hundredths, and how many thousands. And that's a really helpful way to determine which of these decimals is in fact the least or the smallest amount, and which is the greatest or the largest amount. So the first thing I want to do is talk about number 1 here. We have 6 ones, and you'll notice in all these other decimals, I don't have any ones. So we have 6 wholes. 6 is actually going to be my greatest number right here, at the end here. The next one here is 0 and 56 hundredths. So how do I show 56 hundredths? I first want to look at my hundredths grid, and I'm going to shade in 56 of those. So that's 1, 2, 3, 4, 5 columns, because they each have 10 in them. And then I have to shade in another 6 boxes. Okay, so if I shade all of that in, this right here represents 56 hundredths. You can also think of breaking this down into 5 tenths. So I have 5 columns, each one is a tenth, and then I have 6 hundredths, or these 6 smaller boxes here. The next one here is 0 and 60 thousandths, because we move 3 decimal places to the right, and we have the thousandths column here. So 60 thousandths. So if I use one of my thousandths grid and I were to actually shade in 60 of them, there are 10 thousandths in each little box here. So I have to shade in 6 of these boxes. This is 60 thousandths. Now if you just look at the tenths column, you'll see that there are 0 tenths. So you can tell right here that I have not actually filled in one entire row yet. I have less than 1 tenth. I only have 6 out of the 10 boxes there to represent the tenth, or what we would call 60 thousandths. All right, the next one I'm going to look at is also is the next one here is 0 and 6 tenths. So if I use my tenths grid, I can shade in 6 of these. Okay, 1, 2, 3, 4, 5, 6. And this represents 6 tenths. You can see here that that's actually a little bit more than half of my entire grid. And then finally, the last one is 0 and 56 thousandths. So again, I'm using the thousandths grid, and this time I'm not shading in 60 of them. I only shade in 56. So remember, each one of these boxes was 10, 20, 30, 40, 50, and then 6 of them. 5 would be the first half of the box, and then a little bit more. So this right here is 56 thousandths. So if we look at our visual model, you can see that 56 thousandths is less than 60 thousandths. So my inequality sign opens up to the larger number here. And in fact, 60 thousandths is not even quite a tenth, is definitely less than 5 tenths and 6 thousandths, or what we would say 56 hundredths. And 56 hundredths here is just a little bit less than 6 tenths. We have 5 tenths plus 6 thousandths, whereas in here we have 6 tenths. And then finally, the greatest number here is 6, representing 6 whole. So that's how we would compare these decimals from the least to the greatest.